Hello everyone. Um, so today we will do a tutorial of Amplicon Metagenomics in Geneious Prime software. So we will get the required Amplicon data first in this, and then we will be clustering the reads using the de novo assembler. Then we will do the blast of the assembled hits, and we will create a taxonomy database of it. And then finally, we will classify the Amplicon data with the sequence classifier. So for this, we will generally use the tutorial which is provided by the Genius tool itself. So we will go on that. So just type Amplicon metagenomics using Genius and then go to this website. Then you will see this download tutorial and sequences. So you can uh, just download it. Yeah. And now you can go on the Genius Prime tool. You can get its free trial version. You can just download it. As you can see, I have 28 days, 14 hours left. So yeah. So go on this tool, and then you will on the first interface only you will find like this interface at the home, and you just have to do nothing. Just make one project. So just click on local, then right click the new folder and just give any name. Let's say I'll give metagenomic analysis. Okay. Now, as you have made this folder, uh, we'll go on. I- Uh, we'll go on the downloads, and we'll just drag and drop this whole file here, which we downloaded. Okay. Now, as you can see, uh, this is the SRR 7140083 5000 50,000. So this file actually contains 50,000 paired reads of 16S amplicon. So this is basically a subset of a data set, but they have just taken the 50,000 reads just to make everything go smoothly, and there should be less uh, required timing. I mean, we don't need to wait for the things to get done fully. Okay, so now we will do one thing. We have to trim this. We have to actually pre-process the things first. So we will go to, so yeah, we'll go to annotate. We have to first click it, then annotate and predict, and then, okay, then trim with BUD. Okay. Now we have to just do the following things. Just do this following parameters. Okay, orders to SQ and sequence 158 sequences. Then right end 27 100. In low quality also make it both ends. Instead of minimum quality, we'll put 30 and okay, we'll make it 24, then 100, and yeah, just click OK. It will just trim the things for you. Then you will see, uh, you can see the trimmed version of this file here. Now, to merge the reads, we will use the BBM merge tool. So, which is like built in this Genius Prime only. So, select your trimmed read set from the previous step, like this one, the trimmed one, and then go to sequence, then merge paired reads, and usually like these settings are there. So we will put the merge rate as high and click on OK, and it will do this work. You will get the two files. Um, One will be like the things is that the reads cannot be merged usually because they are too short after a quality trimming, as these are in the files named trimmed but couldn't be merged, and the trimmed merge reads, that is this one. So these are the merged reads which we have in a file. So click on this file and then go to the length graph. So this one, length graph. And you can see that after merging a few sequence are either much shorter or larger than the expected product size of around like 250, right? Base pairs. So the longer the sequences may either be contamination or regularly merged sequences. So we will remove this. And we also want to remove the very short sequences as they do not contain enough sequence to be correctly classified. To extract the read, we want to click uh, extract button, this one, and just do the things on 50 and 260. Okay. And just click on OK. Uh, Now, um, we will like now we have to perform a assembly for these things. As you can see here, it is trimmed and merged, which we did right now. So Amp so we have to do the de novo assembly now. So Amplicon data sets from NGS sequences typically contains the millions of reads, and it is not practical to blast each sequence to assign taxonomy. So instead, we will define an operational taxonomic unit by clustering the reads by similarity. So we can then use this blast results as a target taxonomic database with the sequence classifier plugin. Okay, so in the step in which we are doing de novo assembly, um, we will customize the things to make it run smoothly. So we just have to do one thing. We just have to click on this file, trimmed and merged, and then go to align and assemble. It will be in the tools, align and assemble. Then go to de novo assembler. Okay, and set the sensitivity to first low sensitivity and fastest to load the high stringency settings in this one. And then go to the sensitivity and to custom sensitivity. So I will show you how it is done. So first, do a low sensitivity. Then this is okay. Then trim the sequences. Then do not trim. That is okay. Um, then custom sensitivity. That is also okay. And let's change it to first custom sensitivity. Then we can get more options here. Then you have to click, you have to check this thing, uncheck, I mean, then allow gaps. Maximum read will be 1, then minimum overlap should be 100, then ignore words will be 200, and mismatch per read will be 2%. Minimum overlap identity will be 98, and 1 for 10, 16, 4, that is totally okay. And then since settings, events of folder we don't want, but okay, we'll check this. And yeah, I guess we are good to go. The speed is also okay. Everything is okay, I guess, according to me. And yeah, I guess we are done with this, and we'll just click OK to start. And you can see it is passing the things. It is assembling through de novo assembler. Usually it will take, I guess, some 5 to 10 minutes mostly. And actually, it's good that the data set is already trimmed. And before trimming also, it was already less in size. So it shouldn't take much time. So once completed, you will see a new folder containing assembly reports under the tutorial folder. So select that folder. So we have to actually select that folder and then we have to view the assembly report. So yeah, we got the de novo assembly things as you can see here fully. This assembly report we have generated consensus sequences and unused list. Will be using this uh, afterwards consensus sequences and unused reads. So for the database, like to blast to a local database, we have to first install a custom blast executables. So I guess it is not there. We have to install it. So we have to go to tools, then add and remove databases, then set up blast services, and then change the blast, I mean the service to custom blast, and everything is, I guess, good to. So just check the location where it is. So it is right for me. It is in C user Shred Genius and then blast. Okay, click on OK. It will do the blast for you. So yeah, our blast custom blast setup is, I guess, done. So now to get a pre-formatted blast database file, so we have to go on this tutorial from which we downloaded the full tar files, and from there we have to go to uh, yeah, so this link, and we have to download the 16S ribosomal RNA tar gset. So yeah, we downloaded that 16S ribosomal RNA file. So we'll just go to the downloads folder where it is, and then we'll just extract. Now, as you can see, all the files here, we have to copy all those files, and where your custom blast location was, we have to go there and paste that files. So for me, it was in users, Shrey, and Genius. And you get this blast file when you do the custom setup of the blast in the Genius tool. So, okay, so we have to go in this folder and we have to paste everything. Okay, and now, yeah, so we have added all these files into a blast folder. Then actually we have to do is we have to restart our Genius so that it picks up the new database which we have just given. Okay, so I hope it has taken its new database. Then we have to just do one thing. We have to select this consensus and this one unused reads. So just press Control and it should select both these files. Yeah. Now as we have selected this blast, both the files, and then we have to click the blast button here, and then we have to just put the parameters. For us, the database is 16S ribosomal RNA. Then program is megablast, results are hit table, retrieve will be matching regions with annotations. Yeah, and maximum hits will just put one. So the reason to set the rest of the settings as like this, we have put the maximum hit as one, uh, and we'll retrieve the matching regions with annotations as this will retrieve the taxonomic information from the database fully. So we have set this maximum hits to one because um, it will take the total number of GPUs on our machine. So for me, it is total number is eight. If I put one, then it will just take one of my GPU and it will run the things for me. So it is good if we do this only. And in the more options, we can this low complexity filter. Then scoring is 1 to 2. Gap cost is linear. Then maximum E value we have to set like 1 e raised to power minus 5 and make it -1. And maximum target sequences will be 100. And requests, we don't need those things. And yeah, I guess we are good to go. And we will just click on search. It will do the blast. So when the search is there, so we are seeing one dialog box showing an error, I guess. So it is like these are like most likely either contaminants or incorrectly merged sequences. So that's why we are getting this type of warning. So for each query that does return a result, you will see one blast alignment document in the document table. So select the alignment view tab to view the alignment between the query and the hit of each document. So it is just okay. We'll just put in make sure. For me, I guess uh, for doing the blast, it is taking much time for me. So if it is done, we will make its part two. In the part two, then we will just create a database from the hits which we'll get, and after that, I guess it will be everything good. So yeah, I guess it will take some time for me. So we will just see the next part in the next video. It will be a part two of software Genius. And yeah, see you in that next part. Thank you so much. Bye bye.